When you live in a cold place like I do, these whole home humidifiers are great. Which is why it's such a shame that they're also so terrible. What do I mean by that? Well, if you've got one of these, or you are looking into getting one, you should be aware that they need much more attention from you than you might expect. Not only can these rather easily fail in such a way that can cause catastrophic damage to your home's heating system, but they can also cause significant damage to your home itself if you simply let them run unattended. See, the thing that makes them great, the ability to add lots of moisture to the air very quickly without you having to do anything, also makes them a problem when the temperature outside gets very cold. But today, I am going to fix that problem by giving it just a little more smarts than it had before. First though, a little backstory. In 2021, I made a video on freestanding humidifiers, and the comments were filled with folks wondering why I didn't talk about centrally ducted humidifiers like this one beyond a basic mention. Well, partly that's because back then I was living in a different home and I didn't have one of these. But the bigger reason was that if you want to add a humidifier, it's a lot easier and cheaper to buy one that you just plop somewhere and fill with water. Many of them are large enough to work just fine as a whole home humidifier. Plus, freestanding units don't care what kind of heating system you have. So if your home is heated with radiators or some other kind of ductless heating system, like certain kinds of heat pump, those will work fine. The humidifier I'm talking about today requires both a centrally ducted heating system and a plumbed connection to a water line. So it's not universal, and it's much more involved. And as I already said, these things come with significant risks that you really need to be aware of and monitoring. I'll explain those shortly, but let's start with a quick overview of what this thing is. There are several types of these things on the market, but most of them are similar to this one. Inside is simply a fan, which blows air through this wet pad made of absorbent material. The whole thing is mounted to a giant hole cut into my HVAC system's ductwork, and when it's running, the fan draws in some of the air coming up from the furnace through the sides here, and then forces it through that wet pad, where it will absorb moisture before rejoining the airstream and getting distributed throughout my home. It's quite a simple device. Where's the water coming from? It's coming from right here. When the humidifier is running, this solenoid valve opens and a small but steady stream of water is fed through this line and up to this nozzle, where it's then distributed through these drip holes and onto the pad. That makes the pad soaking wet, and in fact, once it's saturated, you'll see a trickle of water coming out the bottom. The valve is deliberately letting more water through than the air going through the pad can absorb, so you invariably end up with some wasted water. I couldn't tell you exactly how much water is being lost here, but I can tell you I have never noticed an increase in my water bill between heating and cooling seasons. So it's not that much. But if you're concerned about that, there are water-saving models available which don't work like this one does, but they have other considerations which I'm not going to be getting into today. Since the pad is essentially always soaking wet, it gets pretty gross and needs regular replacement. How often you'll need to do that depends largely on your water hardness and how large your home is. I have a fairly small home, so this thing doesn't run that much, and I can usually get away with changing it at the start of each heating season. But even still, this is what last year's pad looks like. It used to be white, and now it's pink and crunchy because of all the calcium it's filled with. Delicious! But it can be much worse than simply getting a little gross. Remember that thing I said about these needing much more attention than you might expect? Well, one day I heard the water valve open, but I didn't hear the fan start up. And that was because the pad had started to deteriorate, and part of it fell forward and into the fan blades, holding them stationary. I'm honestly quite lucky that it didn't cause any damage to my furnace, because the water valve was still open and getting it wet, so the pad's detached section leaning at a wonky angle could easily have started dripping water down into the furnace. And when I was a little kid, my mom and dad had that exact thing happen, which fried the furnace's control board. So yeah, these are not set and forget. You really need to be cognizant of their operation and needs, and should be checking on it regularly. But anyway, you'll notice that the water line is being fed by my water heater. This style of humidifier generally works better when the water which is saturating the pad is hot. In fact, the manufacturer claims it needs hot water if you're going to use this humidifier. Well, hold on, that part comes later. Now, since this is just a fan that grabs some air from the duct, gets it moist, and then puts it back into the duct, it relies on the furnace pushing air through the ductwork in order to distribute its work and actually increase the humidity in my home. And that means if it were for some reason running when the furnace's blower wasn't, well, it would pretty quickly cause a problem. The air in that ductwork would get extremely humid, and water would start condensing onto things which ought not get wet. Luckily, there's an easy solution to that. Only power this thing up if the furnace is running and blowing air through the ducts. That water valve is powered by 24 volts AC, the same power that your furnace or air handler produces to send through your thermostat wiring for control signaling. The humidifier is also plugged into 120-volt line voltage for its fan motor, but the fan is controlled via a current-sensing relay which detects that the water valve is open. So if the water valve is open, the fan will run. This ultimately means if you wire that water valve across the common wire and the heat signal wire coming from the thermostat, then the humidifier will only be able to operate when your thermostat is calling for heat. This setup not only ensures the blower will be running when the humidifier is on, but it also means the humidifier won't run during a cooling call. So if you forget to switch it off at the end of the heating season, it's no big deal. But the humidifier can't simply run whenever the heat's on. That would likely result in over-humidification, which could be uncomfortable or even cause mold issues. So rather than hook the water valve to the furnace directly, its power wire goes through this humidistat. This is a fully analog doodad which sits in the return airstream and closes a switch when the humidity is lower than your desired set point. So long as that switch is closed and the thermostat is calling for heat, then the humidifier will run. But once the humidifier has elevated humidity to your set point, that switch will open and the humidifier will shut off, even if the heat is still running. It's a very simple control setup, but it works great. Except for when it doesn't. First of all, you may remember from a previous video of mine that my home's furnace is oversized by nearly a factor of 4. This means on most days, it only runs for 2, maybe 3 hours. And that's not enough time for the humidifier to actually be effective. That's a problem specific to my home, but it was very annoying. I couldn't get the indoor humidity to even touch 40% when I wanted it closer to 45 or even 50. However, there was a fix for this issue. Instead of hooking the humidifier's water valve to the heat signal wire, I changed it to the fan signal wire. This meant the humidifier was able to run so long as my thermostat was calling for the blower fan, and by setting a fan schedule on my thermostat which ensured the fan ran for 15 minutes every hour, my humidifier was actually able to do its job. And for the last couple of years, I've been enjoying delightfully moist air in the winter, nice and comfy and free of static shocks. This scenario is why the manufacturer wants this thing hooked to hot water. If it's running during a heating call, the air the humidifier is taking from the furnace and blowing past the pad will be hot, which will help water to evaporate. But if it's running during a fan call, that air is only at room temperature, and the water won't evaporate as quickly. Honestly though, I have a hunch it would actually work fine if it were hooked up to cold water, and the real reason they want it hooked to hot water is to minimize the cooling which would occur as water evaporates. This thing is basically a swamp cooler, and it will drop the temperature of the air leaving the vents if it's running, but if the pad is soaked in hot water, that cooling effect is diminished somewhat and possibly even eliminated. But anyway, that's not important. What is important is this little note you may have spotted on the humidistat. This thing wants you to turn the humidity set point down as the outdoor temperature falls. This is because the colder it is outside, the colder the inside surface of your walls and windows becomes, and that will encourage condensation. This could simply be an inconvenience, maybe you'll have some water puddling on windowsills, but it could also lead to mold growth inside your exterior walls. And you don't want that, which is why it has this helpful little note. There's just one small problem with notes like this, though. You're lucky if people read them, and you're even luckier if people remember about them. I'm a people, and I have forgotten about this several times. Usually what happens is the temperature plummets overnight, and when I get up, the windows are soaking wet. So then I go downstairs to the furnace closet. Quick reminder for you home builders out there, this can all just go in a closet. It never has to go in an attic. If you're doing that, you suck at planning, and I promise everybody out there, the 20 square feet or so taken up by this stuff in the floor plan is absolutely worth being able to get at it without a ladder. Priorities, man! Get some! As I was saying, I go downstairs to the furnace closet, turn this down, and then when the cold snap is over, I'll wonder why it's not as comfortable as I'd like it to be before remembering, oh right, I turned the humidistat down, and then I turn it back up. Given all that hassle, it sure would be nice if there were humidistats out there that were aware of the outdoor temperature and could automatically adjust the indoor humidity set point down during those cold snaps. Oh wait! Those exist! But, well, gosh darn it, they're gonna need a wire run to an outdoor temperature sensor. And this furnace closet is pretty much in the dead center of my home. So that's gonna be annoying. The easiest thing to do would be to run a wire across the garage and maybe slip it past the garage door seal, but I didn't like that idea, and I really didn't like the idea of drilling holes in walls or having random wires going all over the place. I've lived in my home for over 3 years now and have been lamenting the difficulty of installing an outdoor temp sensor for a better humidistat the whole time. And then, about 2 weeks ago, I finally remembered about that pipe that brings in outside air for the furnace. Yeah, this pipe here, it goes all the way outside. The point of this is to allow the furnace to have combustion air without creating negative pressure in the building. When this panel is closed up, the combustion section of this furnace is effectively outdoors. It draws in fresh air through here, which brings in enough oxygen to set some methane on fire, and then pushes the exhaust gases out this other pipe. And, well, I could have just run the outdoor sensor wire through this pipe the whole time. Yeah, better late than never. Now, quick note, some of the fancier thermostats out there are able to control a humidifier directly. I don't have one of those, I just have a basic Nest, which irritates me for several reasons, but mostly works and I somewhat begrudgingly put up with. Luckily, the people who built my home were kind enough to not cheap out and actually ran 7-conductor thermostat wire between my furnace and the thermostat. And this means I could upgrade to a fancier Nest or some other smart thermostat which knows the outside temperature through the internet, and then allowed it to control the humidifier. But quite frankly, I am trusting internet-based solutions less and less these days, so I decided not to go that route. Instead, I searched for a new dedicated humidistat, and then I discovered, wow, this is a much rarer product than I imagined. I mean, in hindsight, I kinda get it. When you buy a humidifier, it's going to come with one of these, but my humidifier apparently came with this dumb one, and I want a smarter one. And since apparently nobody but specialty supply houses stocks these things, off to Amazon I went. I found this Honeywell model as well as this Aprilaire model, and this suspicious clone of the Aprilaire model. Since I have an Aprilaire 700 series and this claims to be compatible with that humidifier, I figured I'll just get the Aprilaire 60 humidity control. So I did. Annoyingly, the product listing gave no information on how long the outdoor air temperature sensor wire was. I'd need about 30 feet of wire, and I figured it would be reasonable for them to include perhaps 50 feet of wire, but nope, it was about 2 feet long. No big deal, I have a soldering iron and I know how to use it. So the first step was to run a wire through that pipe. I made a stop at everybody's favorite suspiciously cheap tool store and got myself a suspiciously cheap 50-foot fish tape. I'm sorry, no, it's a 50-fish T-ape. I tried to run the fish tape directly through where the pipe ends inside the furnace, but I wasn't too hopeful that that would work as there's a lot of bendy-bendy in those pipes. And indeed, it didn't work. No big deal, I figured I'd just drill a hole in this last 90 here, which was probably the start of a straight shot all the way to where the pipe comes out the wall. After double and triple checking that I was about to drill through the intake pipe and not the exhaust pipe, I made my hole. And the fish tape went in nice and smooth for a good long while, but then it hit something. I tried and wiggled, but it was just not going to budge. That was annoying, but then I remembered a trick I saw on the internet somewhere. I took some lightweight twine and tied it to the end of a shopping bag, and then I stuffed it into the pipe. Then I went outside with my vacuum cleaner, which had an attachment that fit nearly perfectly into that pipe, and gave it a toot. I am terribly sorry that I left my mic kit plugged into the camera because there's no sound for this clip, but I'll dub it with what I imagine it sounded like. I honestly could not believe how well that worked, but I was sure glad it did. Too bad I already drilled that hole, I guess. With the bag and the twine now at the other end of the pipe, I pulled it out and tied a wire to the end of the twine. I wasn't planning to use speaker wire for this, but since this pipe is apparently twistier than I realized, I wanted something relatively thick and strong. Then I went back inside and started pulling on the twine. It was going so well, but then... But! A Christmas miracle! It made it past that hole I drilled, and with some picks, I was able to get it out. Good thing I already drilled that hole, I guess. I pulled out about 10 feet of wire from that hole, and then I went outside, cut it to length, and soldered the sensor wire to the new end I just made. Then I went back inside and pulled the wire back until the sensor was dangling down at the very end of the intake pipe. And that's where I decided to leave it. Then I taped the wire in place and made a big old booger of silicone to seal up that hole in the pipe. Now some of you, including the writers of the instruction manual, might be concerned about how close the intake pipe is to the exhaust pipe, but I am confident that this location is fine. For one, when the furnace is running, it will be drawing fresh air up and through the tube past the sensor, so the heat from the exhaust shouldn't matter. My water heater exhaust is also in this area, which could potentially affect it, but unless I'm actually using hot water, the water heater only comes on for about 5 minutes every few hours or so. And one day, I want to get a heat pump water heater. I could have, of course, actually pulled the wire out of the bottom of that pipe and mounted the sensor somewhere if I were concerned, but I wasn't, so I didn't. Alright, with the outdoor temp sensor in place, it was time to install the new humidistat. It needs a 3/4 inch hole in the return duct to get a measurement of relative humidity. And I was hopeful the existing humidistat would have a similar hole underneath, but no, that one needed a big ol' hole cut in the sheet metal, which now presented me with a problem. I elected to seal that hole with some duct tape and mount the new humidistat lower down. I didn't have a 3/4 inch drill bit, so I simply abused my 1/2 inch drill bit and made this beautiful hole. But with it mounted here, it will now be able to know the humidity of the air which is entering my furnace. This is something that I don't quite love about this humidistat. For my home, it's perfect. I don't actually have any return ducting at all. The enclosed bedrooms upstairs have vents installed above the doors which pass air into the hallway, and the hallway leads to a switchback staircase which goes all the way down to the lower level where the furnace is. And since the main level is basically one big room, the staircase itself is the return air path, and all the furnace needs is one giant intake vent at the bottom of the stairs. That's what's on the other side of the duct I've just attached the control to. My home's setup means that whenever the furnace blower is running, the humidistat is going to get a pretty accurate reading. But I can think of plenty of cases where it would be better for the humidity sensor to be somewhere else. In those cases, you might be better off getting a fancier thermostat which can control a humidifier remotely. But if your home's HVAC system was designed reasonably well, like mine was, taking a reading of the air entering the furnace or air handler should work fine. And with it now mounted, all that was left was the wiring. Here, things are drastically different than before. This humidistat has the capability to force the furnace fan to run. If it hasn't gotten a heating call in an hour, it will kick on the blower so it can stir the air up for a while, get an accurate humidity reading, and then, if it's too low, it will switch the humidifier on and keep the blower running, regardless of what the thermostat's commanding. This is a pretty neat feature, and it means I can remove the fan schedule from my thermostat. But it also means this now needs a way to control the furnace. But in addition to that, it also wants to know if the thermostat is calling for heat. So it needs some pretty significant wiring changes. In fact, it wants to be connected to R and C, giving it a 24-volt power source from the furnace, W, so it can see a heating call in progress, and it wants me to disconnect the thermostat wire from the G terminal on the furnace and instead connect it to the G terminal on the humidistat. Then I need to run a new G wire, called GF, back from the humidistat and land it on the G terminal in the furnace. This setup is what allows the humidistat to force the furnace blower on, but it will still pass a fan call from the thermostat through as normal. And finally, of course, I need to connect the humidifier's control wires to the two H terminals on the board and the outdoor temperature sensor. With that done, all that was needed was to turn the furnace back on and test it out. Hope I didn't blow anything up. I think the outdoor temperature is high enough for it to run if I turn it to 6, but we'll see. So the board woke up, and the relay definitely clicked, and it's telling me the humidifier is running, but the humidifier is not actually running. Well. Alright, with the help of a multimeter and some troubleshooting, I have figured out what's going on here, and now I'm mad. So, this thing comes with instructions for hooking it up to an Aprilaire 700 series humidifier, which is what I have. And it has a footnote about if your humidifier was made before 2007, apparently they've been making them like these forever, there's some difference in the wiring. Well, this humidifier is definitely newer than that, but it's not working. Well, it turns out I don't have a 700, I have a 700M. And you would think, right, that M stands for manual. The only difference between those models is you get the manual control, the one that I just replaced, or this digital control. But in fact, the 700M gets its 24 volts AC externally from the furnace, and the 700 automatic version has its own 24 volt transformer inside, and all this is doing is bridging these two contacts through this relay. But the manual humidifier needs to get 24 volts AC, which is going to be possible with this. I have to do a little bit of sanity checking to make sure I wire it correctly, but I'm gonna have to jump either R or C over to one side of this, and then basically have that relay send 24 volts up to the humidifier like the original control. Now, why on earth does Aprilaire choose to distinguish them in this way? I don't know, but it's really frustrating, and they clearly don't want people figuring out how to wire this digital version to the manual one because they just don't even tell you it's possible. But it's totally possible. This is just a relay. One of these relays does the humidifier, the other relay forces the furnace fan on, but they do not give you a wiring diagram for how to use this with the manual model, even though it's completely possible. I've been meaning to make a video on right to repair for a while. This isn't quite part of that, but man, this is dumb. Okay, my modifications are complete. Now this is going to look very confusing because I don't have, almost none of these wire colors are correct. I'm actually using garage door opener sensor wire. Yeah, but it should work. Basically, I now have red and blues, this is 24 volts in common, taken off of the input, and then I have a separate lead for them. So now, this thing and the humidifier are wired in parallel, but the humidifier's return, it's landing on one of the H terminals, and then the other H terminal is coming back to this common point. So basically, the humidifier would run all the time if this relay is closed, but when the relay is open, it shouldn't run. Now, there's really nothing left to do except turn this back on and hope for the best. Now, I know it's safe to do this because the worst thing that would happen is I will blow the furnace's power supply fuse. And it's probably an automotive fuse. I may even have a spare on hand, but it will be easy to get a replacement if I need it. It's part of how I know it's safe for me to be doing this nonsense. Here is the moment of truth, part 2. Okay, it's on. We're going to blower activation. I'm going to turn that to on, crank this up all the way, and hopefully the humidifier comes on. What is this test? Oh, well that works. And look at that, the humidifier's running. Now, is the blower actually running? It's hard to tell when the humidifier is on as well. Oh, for sure it is. So that worked correctly. I want to make sure this actually shuts off now. Awesome. With that rather ugly but functional wiring modification, this is now working as I expected it to the whole time. The humidistat can now energize this relay, which forces the furnace fan to run, and that allows it to perform its own check of the ambient humidity level on an hourly basis. If, during that check, it finds that it's lower than the set point, it will then energize this relay which, thanks to those horrible jumpers and wire nuts, will now send power up to the humidifier's water valve, which will switch it on. And, of course, that will increase the humidity in my home. But once it reaches the set point, the humidity sensor will detect that, at which point it will turn the humidifier off. That will all happen regardless of what my thermostat's doing. If, though, my thermostat is commanding the heat to run, the humidistat is now aware of that, thanks to the fact that it's hooked up to the W terminal on the furnace board. So, as before, if the humidity is below the set point, it will close the relay and send power to the humidifier. And once it's satisfied, it shuts the humidifier off. Now, none of this is really new. My old setup with the humidifier connected to the fan terminal and with my thermostat forcing the fan to run for 15 minutes every hour accomplished the same thing. See, I also went into my thermostat's programming to make it command the fan during a heating call, something that's not necessary for my heating system to work, but which allowed the humidifier to run during a heating call too. So when it comes to the basic functionality of the humidifier, I haven't really changed anything. But now that this control knows what the outdoor air temperature is, I no longer have to think about that. It will automatically reduce the humidity set point as the ambient temperature outside falls. This chart here explains how the humidifier will adjust the set point based on the outdoor temperature reading. The recommended setting, 5, will allow the humidity to get as high as 45%, but will start lowering it when the outdoor temp is 30 degrees Fahrenheit, which is just a hair below freezing. I know that my home can handle 45% at that temperature just fine, so I decided to set it to 6. And actually, this is my biggest disappointment with this thing. I would like setting 6 to shoot for 50% humidity when it's above freezing outside, but the highest this will ever go is 45%. That's not a big difference, but I can notice it. Still, I will happily sacrifice that for the peace of mind that this will automatically reduce its output in those cold snaps. I haven't had this installed for very long, but my thermostat, which has a hygrometer in there, is telling me the indoor humidity is hovering around 45%, so it's doing its job and seems to be accurate. Or, I guess, at least my thermostat agrees with it. The other thing I don't like about this? It won't tell me what it thinks the outdoor temperature is. It should throw an error code if the sensor goes bad, but what if the sensor is simply drifting over time? I'm not going to know that unless the drift is bad enough to cause it to over or under humidify. Since I've installed this, the outdoor temperature hasn't fallen much below freezing, so I'm not even sure yet that it's working as intended. That's cool since, that's the whole reason I did this. But we're supposed to get a cold snap shortly after Christmas, and I'll do one of those community posts once we've gone through that. And I'll pin a comment here too. Aside from the absolute ridiculousness that was having to figure out my own way to get this Aprilaire humidity controller to work with my Aprilaire humidifier, I am very happy to have made this upgrade. But to circle back to the beginning of this video, While the main point of doing this is to make my humidifier something closer to set and forget, it's still absolutely not set and forget. The potential for leaks is still there. The potential for a deteriorating water pad is still there. And while I hope its outdoor temperature sensor will work reliably for years to come, the potential for too much humidification if it starts drifting in the wrong direction is still there. I will absolutely still be monitoring my home's humidity level and the function of the humidifier, and I suggest that anybody out there with one of these things check on it at least monthly and preferably weekly. That, I think, is the biggest argument for choosing a large, freestanding humidifier over one of these things. Sure, it's annoying to fill those up with water every day or two, especially considering that you'll need to use a water treatment product with those fill-ups to prevent odors and mold growth. And of course, they take up space. But when you have to keep interacting with it in order for it to keep working, you'll be more likely to notice problems. Plus, if its tank were to start leaking, at most you'll have a few gallons of water on the floor. This thing's plumbed to full water pressure, which means leaks could be much more catastrophic. I have a floor drain in this furnace closet, so I'm not too worried about that, but still, it could cause major damage to my furnace. And that's not good. But I must admit it has been very nice to have this machine keeping the air comfortable without having to fill up a weird 2-gallon bottle every couple of days. And now that the humidistat knows the outdoor air temperature, I'll be slightly more at peace knowing that I can't forget to turn it down. I'm still going to be checking on the humidifier every week or so to make sure the fan is spinning and that there isn't water where there shouldn't be. Plus, of course, I'll be checking that the controller I installed actually does its job. Assuming it does, though, this is as close to set and forget as you can reasonably make one of these. And that makes me happy. A few things I didn't mention in the main body of the video. First, like my old setup, I'll have to remember to turn this off when the weather gets warm. If I don't, it may try to add humidity when that's the last thing I want. Yay, Midwest! Second, at time of filming, I haven't yet verified whether or not it knows the thermostat is commanding the fan. It should, but I didn't think to actually test that before I got here and shot the talking head. Here's the answer. I just confirmed that yes, it does turn on the humidifier when the thermostat gives it a fan call, so that is working as I expected. And third, this thing's humidity sensor does a reasonable job, but I have noticed that the displayed humidity falls quite dramatically as soon as I open the door to the furnace closet. It drops by about 5% even when the blower is running. This is a bit puzzling to me as it's in the same room that the furnace is pulling air from, and based on what my thermostat is telling me, it doesn't seem to matter, but clearly the sensor is being affected by the air around it and not just inside the duct. That makes complete sense based on this thing's design, and it would really be improved if it had some sort of remote sensor you could shove deep into the duct. Plus, that would mean you could mount this control somewhere it's more visible if you wanted. I know there are plenty of climates out there where the idea of wanting to add moisture to the air is abhorrent, but I'm surprised how terrible the options seem to be for central ducted humidifier controls. They are simple things, yes, but we could be doing so much better. Humidistat the whole time, and then about 2 weeks later, oh shoot. Yeah, it used to be white, and now it's pink and chunky crunchy. Crunchy, not chunky. Ugh. This thing is basically a swamp cooler and will drop the temperature of the air leaving the vents if it's running. But the pad... I missed the word if. Then I taped the wire in place and made it farts. That's what's on the other side of the duct. Farts!